Hello everyone, and welcome to Earth Archives. Today, we're going to discuss an incredibly grand question. How big is the universe? Does it have a boundary? Is the universe infinite or finite? Or perhaps, the universe has no boundary at all? These questions might sound a bit difficult to grasp, but in fact, scientists have spent many years trying to figure out the answers to these questions. Today, let's explore these profound cosmic mysteries together and uncover the seemingly unsolvable secrets of the universe. The beginning of the universe. According to modern scientific theories, the origin of the universe can be traced back to an event known as the Big Bang. The name might sound exaggerated, but it is the best way to describe the birth of the universe. Around 13.8 billion years ago, the universe existed as an extremely dense and hot point. Imagine that the universe back then was even smaller than an atom. Yet it contained infinite energy and matter. Its density was so high, and the temperature was so incredibly hot, it's almost impossible to comprehend. However, at a certain moment, this dense point underwent a violent expansion. This is the Big Bang. The Big Bang wasn't an explosive event in the conventional sense, but rather a rapid expansion of space and time. At that moment, all the matter, energy, space, and time of the universe were created and began expanding instantly. This expansion occurred at an incredibly fast rate, far exceeding the speed of light. The process of expansion wasn't an outward explosion. Instead, the very space of the universe itself was expanding, and all galaxies, planets, and light were pushed outward along with the space. As time passed, the universe began to cool. The early universe was filled with high-energy particles, photons, and basic elements, such as hydrogen and helium. These elements interacted with each other and gradually formed more complex structures. Millions of years later, as the universe continued to cool, these hydrogen and helium atoms began to combine, forming the first nebulae and galaxies. These nebulae eventually became the galaxies and stars we see today. Around a few 100 million years later, these stars began nuclear fusion reactions, creating more elements. These elements not only formed the foundation of planets and other celestial bodies, but also provided the necessary conditions for the birth of life. Some of these stars, after billions of years of existence, eventually died and exploded into supernovae. The explosions of these supernovae scattered heavier elements like carbon, oxygen, and nitrogen across the universe, and these elements became the building blocks of planets, life, and the Earth itself. So, what was the universe like before the Big Bang? Well, this question doesn't have a definitive answer because, before the Big Bang, neither time nor space existed. Simply put, before the universe was born, it was as though there was nothing at all. The boundary of the universe. In the vastness of the universe, stars and galaxies shine like brilliant pearls, twinkling against the dark cosmic curtain. However, beyond these familiar celestial bodies lies a secret and mysterious place, the boundary of the universe. Perhaps you've gazed up at the night sky and wondered what the edge of the universe might be like. This place is not easily accessible to us, but it remains a dream destination for countless scientists and astronomy enthusiasts. So, what is the boundary of the universe? How far is it from us? Is it a hollow darkness, or is it filled with unsolved mysteries? The boundary of the universe is not something that can be defined by walls or borders like the boundaries on Earth. Scientists tell us that the universe's boundary is not a fixed edge, but rather a constantly changing range as the universe expands. According to modern cosmological theories, the universe doesn't have a definitive end. It has been expanding continuously, and the rate of expansion even exceeds the speed of light. Therefore, for us, the boundary of the universe is not only a geographical limit, but also an extension of time and space. The most intriguing part of exploring the universe's boundary is that it may hide unknown realms. While we can observe many distant galaxies, a portion of their light cannot reach us due to the expansion of the universe. These galaxies and celestial bodies are moving farther away, and their light will eventually never be able to cross the endless space. Perhaps In that distant place lies a world beyond our imagination, and the secrets it holds might become the key to future scientific breakthroughs. Such theories tell us that the structure of the universe may be like this: finite, but without boundaries. This kind of universe is like the surface of the Earth. No matter which direction you go, you will eventually return to the starting point. Sounds magical, doesn't it? The expansion of the universe and the curvature of space. Starting from the Big Bang Theory, the expansion of the universe is a long process that began at that very moment. About 13.8 billion years ago, the birth of the universe didn't start from an empty void, but from an incredibly dense and extremely hot point that began to expand. This Big Bang was not an explosive event, but a rapid expansion of space itself. As the universe expanded, all matter and energy spread out during this process, continuing to this day. You can imagine this scene. At that distant moment, every point in the universe was so crowded that there was almost no empty space. However, as time passed, these points were pushed farther and farther apart, and the volume of the entire universe became incomprehensibly vast. This expansion is not simply about matter spreading out in all directions, as we might intuitively understand. In fact, the expansion of the universe involves a change in space itself, which brings us to the concept of space curvature. For our intuitive understanding, space might seem like a flat sheet of paper, but in reality, according to Einstein's theory of relativity, space is not absolutely flat but can bend. This concept of curvature may be difficult to imagine, but we can use a simple analogy to help understand. Imagine standing on an elastic sheet. The sheet was initially flat, but if you place a heavy object on it, the sheet will bend because of the weight. Similarly, massive objects in the universe, like stars and black holes, bend the space around them. This is space curvature, and it changes the way we perceive the structure of the universe. With the curvature of space, light traveling through the universe will also be influenced by this bending, which is what we call the gravitational lens effect. When light passes by a massive object, it bends, and this effect can be seen not only near Earth, but even in distant galaxies. This allows us to observe more details from far-off galaxies, and it is one of the fascinating aspects of Einstein's theory. When we think about the expansion of the universe and the curvature of space, we are not just discussing a physical phenomenon, but contemplating how the immense structure of the universe changes and evolves. The universe we live in is exactly in such a curved space. Scientists have even measured it with high-precision instruments, proving that our three-dimensional space is indeed curved. This is not just a limitation of our observation tools. It is the result of mathematical and physical theory. The curvature of the universe and its geometric structure. The mysteries of the universe were first revealed through Einstein's theory of general relativity. He told us that gravity is not simply the attraction between objects, but the result of massive objects causing space itself to bend, which also alters the trajectory of light as it travels through the cosmos. It's like a stretchable fabric that is bent by a heavy object, where every fold influences the path of any objects placed on it. The universe is like this fabric, full of countless bends and curvatures. Whenever we gaze at the distant starlight, whether from far-off galaxies or exploding supernovae, what we see might already be the image of light bent as it passed through the curved space of the universe. These curved spaces are not limited to our view, but our entire universe exists in some form of geometric structure. Imagine this scenario. The universe is a massive spherical surface, with our planet Earth as a tiny point on this surface. No matter how far we walk, we will always return to the starting point, unable to escape the circular boundary. This is what is known as a closed universe. If the curvature of the universe were slightly different, it might take on an open geometric structure, like an endless sheet of paper that, no matter how far we go, will always extend and never return to the original point. This open or closed structure represents the fundamental geometric shape of the universe. When we stand before this vast universe, even the speed of light cannot prevent these marvelous geometric phenomena. Can you imagine? The curvature of the universe means that the distances between galaxies are no longer calculated in straight lines, because in the vast cosmos, the path of light also gets bent. This is like a ball thrown into the air that eventually bounces back to its starting point. This also explains why the light from some distant galaxies takes far longer to reach us than we might imagine, because the light on its journey has passed through countless curved regions. So, how much is this curvature? Current scientific observations show that the curvature of the universe is close to zero, meaning that on a large scale, the universe is flat, suggesting that the universe could be infinite. Observing the boundary of the universe. Over the past few centuries, scientists have continuously advanced humanity's understanding of the universe's boundaries, from the initial geocentric model to the heliocentric model, and finally to the modern expanding universe theory. The universe is no longer a static finite space. Instead, it expands over time, growing larger and more distant, much like a balloon. This expansion seems endless, prompting us to wonder, does this seemingly infinite space have an endpoint? Or what exactly is the boundary we speak of? There's a concept known as the cosmic horizon, which refers to the observable range of the universe that we can currently see. This range is not a definite boundary, but is limited by the speed of light and time. Light from distant galaxies takes an immense amount of time to reach us, and what we actually see is the light those galaxies emitted in the past, not what they look like now. As time passes, these light sources will grow increasingly distant and may eventually never reach our sight. This means that even as our technology advances, we will never be able to truly see the edge of the universe, because the rate of expansion is faster than the speed of light, making it impossible for our vision to keep up with this velocity. Some scientists believe that the boundary of the universe does not exist. The universe itself may be an infinite space that, in some way, loops back. Our universe could be like a giant sphere, and if we walk along the surface of the sphere, we would eventually return to the starting point. This idea is similar to the closed space concept in geometry. In such a universe, there would be no true boundary, just different points circulating within this closed space. If this is true, perhaps we will never reach the edge of the universe because it simply doesn't exist. Inflation theory and the bubble universe. Among the many scientific theories, the theory of cosmic inflation is perhaps one of the most captivating. Imagine this. Billions of years ago, the universe began from an incredibly tiny point and expanded instantaneously, much like a balloon rapidly being inflated, filling an endless space. This is what we call the inflation theory. This theory tells us that the universe was not always as it is now, filled with galaxies, planets, black holes, and even air. In the early stages of the universe's birth, it was merely an incredibly dense, extremely hot singularity. Then, in less than a second, the universe expanded by thousands of times, a process known as inflation. Can you imagine it? In that instant, every part of the universe expanded at an unimaginable speed, stretching the entire space like an elastic band. This expansion wasn't gradual or slow. It was almost instantaneous. As inflation continued, the originally uniform matter began to spread out, forming the galaxies, nebulae, and even the planet we live on, Earth. The essence of inflation theory is that it explains why the universe's structure is so uniform, why the distances between galaxies are roughly equal, and why the universe has such an astonishing scale and fine-tuned order. However, as discussions about inflation theory deepened, a more intriguing question arose: the bubble universe theory. This theory conjures up a vivid metaphor. What if the universe is not singular, but made up of countless different bubbles? Each bubble represents an independent universe with its own physical laws and structure. Imagine these bubbles floating in endless space, each one a brand new universe. Some of these bubbles might have physical laws similar to our own, while others could be completely different. These bubble universes are like worlds within bubbles, where each bubble represents the birth of a new universe. They might collide with each other or even intertwine, yet each bubble's existence is independent. This theory sounds like a dreamlike fantasy, but it deepens our understanding of the nature of the universe. The bubble universe theory is not only a speculation about the origin of the universe itself, but it might also explain why our universe has such a finely tuned structure and continues to expand. The existence of bubbles makes the universe's structure more flexible, allowing scientists to think more deeply about the true mechanism behind cosmic inflation. Perhaps, beyond our own universe, there are many more bubbles, each one an infinitely possible world. The possibility of parallel universes. Have you ever wondered if this universe is the only one? Just like the world we live in, perhaps in some distant corner, there is another universe, and its rules might be completely different from ours. This thought may seem far-fetched, but in the eyes of modern physics, the concept of parallel universes is not as absurd as it seems. The idea of parallel universes originated from quantum mechanics. According to quantum theory, every particle at a given moment could be in multiple different states, and upon observation, these states collapse into a single, determined outcome. Imagine if every choice, every event, led to a new branch, so that each possible outcome is realized in another parallel universe. This means that whether you choose to drink coffee or tea today, every possible consequence of that choice might be realized in a parallel universe. Such a theory is both exciting and perplexing. If there truly is a parallel universe, how does it differ from ours? How do these universes intertwine and influence each other? In some parallel universes, perhaps our world doesn't exist at all, or the historical timeline of the universe is completely different. There may even be scenarios that are entirely opposite to our own. Perhaps in another universe, another version of you made completely different choices and lives an entirely different life. The idea of parallel universes has even inspired many works of science fiction, from movies to novels, with countless stories revolving around this theme. In these stories, we see different versions of ourselves, experiencing different adventures and challenges. Sometimes, these stories are full of romance and excitement, making us yearn for a parallel world where perhaps our lives are better or we have chosen a more perfect path. But in any case, the allure of these stories lies in their ability to temporarily take us away from reality and explore worlds full of infinite possibilities. No matter how vast the universe is or whether it has a boundary, we are just a tiny part of it. Perhaps, in some corner of this vast cosmos, there are countless parallel worlds similar to ours. When we feel lost or confused, we might look up at the stars and think that maybe everything we experience, whether good or bad, could be replayed somewhere in the universe. The mysteries of the universe far exceed our imagination, yet each of our tiny lives holds a unique story in this endless expanse. The universe is so vast, and though our lives are brief, every moment is filled with infinite possibilities. Thank you all for watching. I hope today's content has given you a deeper understanding and reflection on the universe. If you enjoyed this video, don't forget to like, subscribe, and leave a comment to share your thoughts on the universe. See you in the next episode.